Okay, so let's look at briefly at the mechanisms that lead to extratropical transition, starting with this, where we are looking at genesis latitudes for storms that re-intensify or weaken after extratropical transition. Colors correspond to these latitude bands. We are seeing these here. So the ones that re-intensify are mostly born, majority of them are born in the equator to 15 north latitude band, and surprisingly the ones that are born at higher latitude are not necessarily more likely to re-intensify. We already know that the extratropical transition and survival does depend on the structure and the intensity of the cyclone that's starting off as a tropical cyclone. And the ones that weaken also are born either in the 25 to 30 north latitude band or equator to 15 north. So obviously there are many that are born here that re-intensify, and there are quite a few that are born here that end up weakening. So we need to look for those details of the mechanisms that take these cyclones and then either re-intensify them or weaken them. And here again, greater than 30 north latitude, some of them re-intensify, some of them weaken, and this band remains almost the same as well. So there are two patterns here called the northwest and the northeast. So there is a trough pattern where the jet stream is coming down, and composite, this is showing here composite 500 hectopascal height in meters and sea level pressure in hectopascals only below 1008 hectopascal, with shading in 4 hectopascal increments starting at 104. Analysis based on grouping of cases in a northwest pattern here at ET, extratropical transition plus 24 hours, extratropical transition plus 24 hours. So you can see that the transition happens into a very different regime here, and this allows the system to re-intensify in terms of its interactions with the mid-latitude circulation pattern, baroclinic instability, the ED growth rates, the availability of energy from the instability to let the warm core cyclone to transition into cold core re-intensified extratropical cyclone, whereas in this regime it gets into this strong shear barotropic instability, which tends to basically remove the energy from the extratropical transition of the warm core into the cold core. So this doesn't, these don't re-intensify. So this is something that is extracted from looking at a large number of the ones that transitioned. To take that a little bit further, here we are looking at tracks of tropical cyclones that underwent extratropical transition between June to October 1994 to 1998 in a northwest pattern. This is the northwest pattern extratropical transitions, and these are northeast pattern extratropical transitions. The points mark the positions of every 12 hours from 12 hour before to 48 hour after the time transition. So you can see that just in terms of the numbers we cannot say much. These go much more systematically eastward and weaken, whereas these go much more northeastward, let's say, and they re-intensify. So there is definitely that systematic dependence on these mid-latitude patterns that are called northwest and northeast. Since we haven't done much about the barotropic and baroclinic instability in this course, I'm not going to get much more into the details, but we can revisit this figure that we looked at earlier, where we are looking at the annual cycle of regions supporting tropical and baroclinic storm development for the northern and southern hemispheres. So we are looking from the Arctic and Antarctic, and the SSTs, which are the tropical cyclone cyclogenesis regions, and this is the seasonality, so the annual cycle. And then there are colors which show the ED baroclinic growth rates of most unstable modes in greater than 0.25 in the light colors and greater than 0.5 per day. That's the unit of the ED baroclinic growth rate, and that corresponds to the likelihood of the baroclinic energy tipping over into eddy kinetic energy and feeding the extratropical transition or extratropical cyclogenesis, right? What else can I say here? This is for the southern hemisphere, and yeah, so let's look at the analysis of ET that support our earlier statements that the likelihood of extratropical transition for an individual storm depends on the structure and intensity of the tropical cyclone, its thermodynamic environment represented here by the sea surface temperature. So there is a enthalpy flux that also is part of the re-intensification and the transition, or transition and the re-intensification. So transition is just the survival, and then re-intensification is more specific about whether they pick up in strength and the wind strength and the precipitation on the south and the north respectively of this asymmetric tilting pattern of the cold core cyclone that we looked at. Thirdly, the structure of interacting mid-latitude trough represented here by the ED growth rate. And fourthly, the relative location of the tropical cyclone to this trough evident through the seasonality of the ET latitude that is shown. Oh gosh, I didn't include that here, but you remember we saw the seasonality of the ET latitude starting in the lower latitude or starting in the higher latitude, transitioning to the lower latitude from May through November or so. I think you remember that one. Okay, so all these things matter. In other words, mechanisms, again, doesn't seem like there is an incredible typology other than these few features, the trough or the northeast-northwest patterns, and the structure and intensity of the original cyclone, warm core cyclone that's transitioning into extratropical cyclone. Okay, so we will leave it there and look at some examples of which ones will intensify and which ones will not intensify by looking at past cyclones that did or did not do the extratropical transition, which maybe give us a little bit more idea about the these specific mechanisms.